Hello everyone, welcome back to the metabolism series. Today we're going to focus on how the transition step works inside the mitochondrion, and without further wait, let's begin. Okay, so we start with pyruvate outside the mitochondrion. Pyruvate gets inside the mitochondrion via a transporter, and once inside pyruvate gets converted into acetyl-CoA. This is the final point of today's video. So, Pyruvate Dehydrogenase complex is an enzyme which has three parts, as you can see. The first one is called E1 or Pyruvate Dehydrogenase. What this enzyme does is decarboxylation on the pyruvate. It gets rid of carbon in form of CO2. It has the help of vitamin B1, in this case thiamine pyrophosphate. Pyrophosphate means two phosphate groups together. So it's a vitamin B1 with two phosphates. Then this complex steals the carbons from pyruvate to create hydroxyacetyl thiamine pyrophosphate. And then on the second part of this enzyme we have the E2, which is called the dihydrolipoamide acetyl transferase. Don't worry about the name of this enzyme, it's pretty simple. So we start with oxidated lipoate. What it does is it steals the acetyl group to create acetyl lipoate. Acetyl lipoate then gets converted into reduced form of lipoate, so it loses an acetyl group, which is two carbons together. Those two carbons come from the pyruvate, because in glycolysis we make two pyruvates, and if we lose one carbon on each one, we get two carbons in form of an acetyl group. So this acetyl group is basically going from here to here, from the thiamine pyrophosphate to the lipoate. And then the acetyl group is going to combine with CoA, a coenzyme A, to create acetyl-CoA. In this process of going from the reduced lipoate to the oxidated lipoate, electrons are moving, and the enzyme number 3, the dihydrolipoamide dehydrogenase, what it does is stealing those electrons and creating FADH2 from FAD. At the same time, NAD positive is stealing those electrons from FADH2 to create NADH. This NADH is then going to be used in the electron transport chain. As we know, we create two acetyl-CoA, two NADH, since we have two molecules of pyruvate. This is pretty straightforward. The only thing that really happens here is that they steal one carbon from the pyruvate, and since we have two pyruvates, we get rid of two carbons. Those carbons create an acetyl group. The acetyl group is then going to move through these enzymes, and eventually it's going to get bound to the coenzyme A to create acetyl-CoA. Pyruvate, acetyl, and acetyl with a CoA, acetyl-CoA. That's it for this video. Let's see you on the next one.